So hello and welcome to this, the last in our series of Get to Know Your Neighbours. I hope you've enjoyed the series as much as I have, and you're all feeling a little more familiar with some of the Science Park businesses and altogether much more neighbourly. I've really enjoyed it so far. So today we're going to be hearing from three more exciting businesses. So we've got Complete Communications, Chess Dynamics and Modus Labs. They reflect, for me, not only the fantastic diversity of enterprises we have at the park, but also they're each leaders in their respective fields. So we're really delighted to have you. So you'll probably be familiar with the format now. So we'll have everyone talking for no more than 10 minutes if possible, and then we'll have about 15 minutes right at the end for some questions. Please put your questions in the chat or message me them directly if you're feeling shy. So without further ado, on to our esteemed guests. First up today, I'm delighted to introduce Paul Gillam, who is Naval Systems Engineering Manager at Chess Dynamics. We've been lucky enough to have Chess on site for a number of years now, and we've supported them to grow considerably over that time. They are now in residence in the Rally building in our phase 4 at the back of the park next to the bistro, where we fitted out a whole new building for them, including cutting a big hole in the front to put in a big door to facilitate their loading bay and all the equipment they need to get in and out. So yeah, we're delighted to have Chess with us. So without further ado, Paul, I'll hand over to you.
Thank you very much indeed. Good afternoon, everybody. It's a pleasure to be here. I'll just share my screen.
It's always that lovely satellite delay when nothing happens.
Yeah, absolutely.
Here we go, it's coming.
So can you see that?
Yeah, that's perfect.
Yeah.
Okay, so as the name implies, the title of this presentation is Chess Support to Naval Systems in an Evolving World. So Chess is part of the Cohort Group, which is a group of independent engineering experts that work across both the military and the commercial domain. So as part of Chess, we are the Naval Systems Group based here in Plymouth. We've also got our head office in Horsham, and then we have our software experts that come out of a subsidiary company called Vision Force, who are based in Wokingham. We are a fairly niche company. To give you an idea of the size, at our head office, the team up there are about 160. Down here in Plymouth, we're about 25, and in Wokingham, it's about 10 people. So altogether, we're just around about the 200 mark. So it's not particularly large. But what I want to do today is focus on what we do here as Naval Systems in Plymouth. Quick personal introduction. So I've been with Chess now coming up for 9 months. My background is I'm an ex-RN engineering officer, and then having left the service, I worked for a couple of years for Babcock, working on the big new aircraft carriers, and then starting off the program for the Type 31 frigate, which is currently just started building in Scotland. So moving on then. Bear with. Have you got a change now, yes?
Mm-hmm. Yeah, that's okay, right, good. Yeah.
Apologies for that. So as part of the Naval Systems, we here look after what we call the Sea Eagle family. Looking across the screen from left to right. So the FCRO, which is the Fire Control Radar Optical. In the centre, you've got the Fire Control Electro-Optical. We have the Mark 1 and Mark 2. The Mark 2 is the new variant, which we're just developing and coming through to critical design and delivering to our first customers at the moment. The change there is moving from an analog and standard lenses in the cameras to high definition and a digital sensor. And on the right hand side we have the EOS, which is the electro-optic surveillance system. So these are the sensors that we provide, and you can see that with the ones on the left and centre, prefixed by the FC for fire control. So as well as doing electro-optics for surveillance purposes, we also provide fire control solutions. And as we move through the presentation, I'll give you a high-level overview of the sorts of things that we do. And as we get to the back end of the presentation, I've got a short video which hopefully will bring everything together and give you some illustrations of the type of work we do here at Chess. So I just wanted to focus on the new Mark II to just give you some indication of the construct of the head, so that you can get an understanding of what it does. So you can see the head on the left-hand side, and then at the top in the centre, we've got the left-hand cutaway, and then the right-hand side of that, you can see that's where we house the thermal imaging camera. Below that, the left-hand side, we have a daylight television camera and also a laser rangefinder. So what we endeavour to do to provide to naval systems is to provide ships with 24-hour all-weather capability for surveillance and gunfire control purposes. So why do we do this? So very, very important in the military domain, and in particular, what we're focusing here is on the maritime domain for naval systems is situational awareness. So when ships are at sea, it's really, really important that they have good situational awareness so they know what is going on around them. As you can see from the illustration on the right-hand side, indications of what's happening in the air, what's happening around the ship, in near and far, and also from the land side of it. So this is really, really important. So to just take this a step further then, for the Sea Eagle support in the maritime environment, you know, and if you think back, the title of this is in the evolving world. So we have air power, and this is looking at both friendly and hostile forces. We have drones, which I'm sure many of you've seen are becoming more and more prevalent. And in the military domain, these are threats because these can actually carry munitions these days, as well as cameras for surveillance purposes. Then on the right-hand side, the fast attack craft. So this includes both the larger version there and also smaller inshore attack craft. So these are threats to warships for what we call the asymmetric threat. So where the smaller platforms can really present a hazard for larger platforms because these things can be loaded with explosives and then just used to target in suicide type missions against the warship. And then the next one across then, something I'm sure many of you have seen in the news on numerous occasions, the anti-piracy. So those four elements are really the main functions of what the warships use for the surveillance purposes in the head. And you can see then the importance of having 24-hour capability for the daylight and the infrared cameras. And then also when the ship actually finds something through surveillance, it's got the laser rangefinder, so it can actually do ranging on the target to see how far it is from them. Moving across then, on the left-hand side, we've got naval gunfire support. So as well as providing surveillance, here at Chess, what we also do is we do gunfire control. So we work across many calibers of guns, and we support the ships with integration and providing the fire control solution. So moving on, naval gunfire support, what is it and why do we need gunfire control? So just to take a simple analogy, if you think back, you know, children quite often, you know, can stick a tin can up on a wall. You know, I'm sure other than video games, kids still do this sort of thing and throw stones at it. So if you imagine yourself in a vacuum environment, you pick up a stone and you throw that stone to hit the can, then if you're in that benign vacuum environment, then the only things that you're really thinking of is the rate of the throw, so the power that you actually release the stone with or the rock with. Then there's the size of the rock and the effect of gravity that will have on it, that will affect the trajectory of that stone as it leaves your hand and goes towards that cairn on the wall. So if you look at the diagram that I provided here, we've got a 4.5-inch gun from one of the RN warships, and you can see that I've expanded the trajectory from that gun towards the target. So again, taking that in a vacuum environment, the only things that really would be considered is the size, the weight of the shell, and the power, the muzzle velocity that comes out of that gun to fire it, and it would go within that arc. But of course, real life, the real world is not like that, and we don't live in a vacuum. So of course, there's many, many factors that have to be considered when a naval ship is looking to engage a target, either ashore or at sea, on the ground or in the air. And this is really just there to indicate some of those factors, both in the physical and the environmental, that will have influences on the shell, and what we need to deal with to actually achieve the required accuracy. So you can see there's tailwind behind the ship, there's the headwind, there will be a crosswind, the muzzle velocity, so that's the rate in which the shell leaves the barrel of the gun, the ship's speed, because obviously the ship will be moving through the water. Actually on the water, the ship is not stable, so we require a vertical reference unit for the pitch and roll of the platform. We have the curvature of the earth, the rotation of the earth, and potentially, depending on where it is, the speed of the target towards the ship. And as we go to the different levels, you have the atmospheric pressure and the wind at the different levels. So you can see there is a significant number of factors that have to be considered when the ship actually launches. So all of these become corrections and deflections in the ship's combat management system. And that's again part of what we at Chess do, is provide the gun prediction. So we do all of the mathematics, we do the modeling, and then we provide the electronics, the processing systems to be able to actually do that gun prediction. And you can see what I've done there is basically in the center of the diagram, you've got the EOD, the fire control electro-optic, and as a sort of analogy there, you've got the eye, which is the surveillance connected to the brain. So that's all part of what is required to actually pull the solution together to make sure that the ship achieves hitting the target as is expected to do. And
just going to give you a 2-minute warning, Paul. Sorry.
Yeah, that's fine. And so I'll just move on very quickly to give you the video to just give you an indication of some of the things that we do here. Thank you very much.
Thank you, Paul. We didn't quite get the sound on the video, but we definitely got the gist of that.
Okay.
That absolutely blows my mind, the amount of real-time computation that must be going on with all your equipment. So, okay, so thank you so much. Without further ado, second up today, we've got Richard somewhere in the background and Maria Wilson, who are the visionaries behind Modus Labs. They relocated to Plymouth Science Park in, I think, October 2020. Yes. From Thames Valley Science Park, and have established their business together with their shiny new, not so new, laboratory now in our phase 1 building on the North Corridor. Modus Labs work with multinational companies and leading academic institutions, and founded in 2019 by Richard, and are independent specialists for oral hygiene research and development. So I won't go on anymore because Maria will be able to tell us more. So I'll hand you over to Maria. Thank you, Maria.
Thank you, Faye. Hi, good afternoon, everyone. Well, the first couple of sentences, Faye's already introduced who we are.
Sorry.
So, no, that's fine. That's you did it very well. Yeah, Modus Laboratories founded 2009 by Richard, and then I later joined the company in 2017. So yeah, my background is actually pharmacy, but my first job was in research with GSK, GlaxoSmithKline. Right, so yeah, as you said, we moved to Plymouth Science Park in October 2020. We are a contract research company specialising in the oral healthcare industry. Our ethos is for high quality results and products, a rapid response and a scientific focus to grow an idea from concept to product. We offer personalised services, working closely in partnership with our clients for great results. Some of the services we offer include microindentation. This measures the hardness of the enamel surface. This is important as the hardness is related to how mineralized that surface is. We do also quantitative light-induced fluorescence. This is another method to measure how mineralized an enamel surface and subsurface is. We also do hydraulic conductance. This measures the rate and volume of fluid passing through dentine and is a valuable tool for quantifying the effects of dental treatments designed to reduce fluid flow and thus reduce pain and sensitivity. I've just realized I haven't got my PowerPoints up, have I?
I was going to say, do you want to share your screen?
It
just speaks 1,000 words.
Is that
just give it a minute. Can't see anything yet. There we go. We get to see Richard as well now. Don't be shy, Richard.
We're there. Yeah.
Yeah. And then share screen.
It's always good to have people in white coats at a science park.
Your presentation there. That's it.
And then share.
It's coming now, I think. There we go. If you just go into present mode.
Down. Left. No, right.
Yeah.
That's the one.
Right. Okay, so this is just like the introduction one. And then these are some of the services we provide. So yeah, that was hydraulic conductance. And then we also do, we also have a scanning electron microscope. This allows us to image dentin tubules and to visually quantify the level of occlusion. This is important when assessing a potential, dental product. We also do teeth staining and whitening studies using colorimetry and glossometry. We do dental calculus prevention. We have various models for measuring treatments for the prevention of the buildup of calculus, also commonly known as tartar. We do enamel fluoride uptake. We base our methods on the official US FDA monograph number 40 to measure the fluoride uptake from a formulation into teeth. We do profilometry. This is a very sensitive piece of equipment to produce high resolution images of surfaces in 3D. We do enamel solubility studies. So this is a method for measuring the dissolution of your teeth after consuming, for example, something like a can of Coke. We do abrasivity studies. We have a brushing machine to mimic daily brushing routine to measure how abrasive different toothbrushes and toothpaste products are. We also do various sample preparations and stuff. For the past few years, Richard have co-invented and have been developing in conjunction with Dent Therapy a novel oral product called Tooth Boost. So watch this space. Our more recent venture is in microbiology, which we are currently in discussion with Professor Upton. So these are just a few images. The bottom one's quite interesting. This was actually in our lab. Rich was working. There was a whole herd of deer passing by, which I thought was quite pretty. And then lastly, these are some of the clients who, you know, who are currently working with us or have worked with us. And that's it. Thank you for listening.
That's great. Thank you so much. I particularly like the deer guest appearance at the end there. Yeah.
We often see that.
They like that bank at the back of your lab, I think, don't they? It's nice and quiet along there. But if you could just unshare your screen again. So Maria, I have a question, and this is just my own curiosity is, what teeth do you test on?
We use bovine teeth, bovine incisors, and we also use human teeth.
Is there can you buy human teeth?
And we have a license to be able to use it and stuff like that. And obviously we can't just throw it in the bin. We have to dispose of it properly and everything. So it's really hard to get hold of at the moment due to COVID and stuff. But we have a dental clinic that collects for us. And
Excellent. Yeah, no, I was thinking that when you were talking about all the equipment and everything, and I know when you moved in, it was a complete mission with the amount of equipment you've got. What's the sort of life expectancy of the lab equipment that you use? Do you have this kind of constant rolling program of new technology to have to adopt and sort of add to your suite in the lab, or is it pretty standard and stable?
It's pretty standard, but obviously there's updated versions, and then there's always new technology, and if there's a need for it, we will purchase it. Otherwise, if it's like a one-off study, then this is where you're very helpful. We just ask you if there's someone in Plymouth Science Park or at the university that can maybe run the samples for us, or rent the equipment. So that's very useful for us as well. Being a small company, we can't just keep buying these incredibly expensive pieces of kit. But if it's something we use a lot, then we certainly purchase them.
I was thinking that there's probably quite a lot of electron microscopy equipment down on campus that I should probably make you an introduction to the PMC at some point, because they've got quite a lot of equipment that maybe you've used at some point as well. So cool. I have a couple of questions for Paul as well. How much calibration and real life testing is involved with all this equipment? It sounds epic.
So in terms of real life testing, we do some. So the makeup really is here at Plymouth, because as you know, we're a fairly small facility. We have a workshop where we can do an element of testing. The manufacturing is done in Horsham, but in terms of the proper real world, real life stuff, much of that is left to when we get on board the ship. So Chess has quite a well-established pedigree. So it reached its 29th birthday this week. So as not specifically as Chess, but the idea, the concept, and the products that we make, it's now been around for almost 30 years. So we have that pedigree and we have that established piece. But in terms of, taking the example, the new digital Mark II that we're doing at the moment, is a lot of modelling, but once we have manufactured the first, then when we get to the first ship, there'll be a lot of actual proper dynamic testing that we'll have to do. And that's when we find out if our modelling has actually served the need and provided us what we want. In conjunction with that, we're also looking to diversify in terms of our testing, because a lot of requirements that we're getting from some of the customers are more onerous in some areas now, and then particularly in stability. So we're looking to try and get some sort of stable platform that we can have here, perhaps have on a mobile facility. And we do also look to, and we have done in the past, go out to places like Jenny Cliff or take it out, and we are looking for a remote site where we can go out and do a bit more work, because we're upgrading the radar sensor as well. And obviously working on the science park, we can't really test that, so we need to get out and somewhere like Jenny Cliff or whatever, so that we can do proper real world testing.
And does it have to be over water, or can you do it sort of up on Dartmoor in the rain?
No, we can do it over land. We do need to do testing over water, because as you can imagine, with the radar, predominantly we're looking at surface targets, and there's a phenomenon that is called multipath. So what happens is, with the beam of the radar, you've got a certain beam, and as it goes out, you've got the waves which produce, depending on what the sea state is, a glass reflection, so you get bouncing,
okay.
so you get false ranges. So we do need to do it overseas to be able to understand issues like that.
And can you make everything miniature to go into a drone? You know, are you putting your sort of lasers, rangefinders, TVs and everything onto the drone technology? So
in terms of drone, we're on the other side. So unmanned air vehicles are becoming more and more of a pest. We had that issue at Heathrow Airport, you know, and things like that. And we do, at Horsham, we are actually involved in projects for that. So what we are looking at, and we're developing for the maritime domain as well, is counter UAS. So it's a case of dealing with drones. So rather than using the drone as a capability, our requirement and our driver is to provide the counter UAS capability.
Oh, that makes more sense. Okay, well, I think I'll just check the chat. I think that's all the questions that we have. So I will, 3 minutes to go, we're bang on time, I'm so pleased. I just wanted to say a massive thank you to Paul, Maria and Daryl for their really lovely, enlightening presentations today. I know 10 minutes isn't long, but you've done really, really well to cram so much in. So it's very, very much appreciated. And I just love the Science Park for its diversity, you know, and enthusiasm of the staff that work there. So yeah, and I think that really came across today. So just a more broader thank you to everyone that's watched and listened to the series, either live or on catch up over the last few months. We're hoping to be back very soon to celebrate some more PSP successes with our 25-year anniversary themed activities that will be coming later in the year. So until then, thank you so much, and we'll look forward to seeing you all again soon.
Thank you, it's been a pleasure.
Thank you, Faye. Thank you.
Thank you. Bye-bye.